Hello all, myself Janil Popat. We are discussing earth pressure. This is video part 4. In previous videos, we have seen active and passive earth pressure as well as earth pressure at rest. Then we have seen different cases of active earth pressure like dry or moist soil as a backfill without surcharge, as well as submerged backfill and backfill with surcharge. Let us move further to the fourth case given by Rankine, and then moving forward to different basic theories for active and passive earth pressure. So let us discuss active earth pressure theory given by Rankine for cohesion less soils, and in that case with backfill with sloping surcharge. Now we understand surcharge and surcharge angle very much clearly. Let us discuss this through figure. In this figure, you can see a retaining wall having a surcharge which is inclined. Here you can see green lines which are showing ground line and which is inclined with an angle beta. So it shows a surcharge with an angle beta surcharge angle. In this case, the pressure PA will be taken as K into gamma into H. But what will be the K value? That will be the key for this theory. K value given by Rankine is like this: cos beta into, in numerator, cos beta minus under root cos square beta minus cos square phi upon cos beta plus under root cos square beta minus cos square phi. So you have to calculate Ka, coefficient of active earth pressure, with this formula. Then it is very simple. Pressure can be calculated as Ka into gamma into H as usual, and pressure force Pa can be calculated as 1/2 height into base, that is 1/2 Ka gamma H square as usual. So this is case 4. Here, if the surcharge angle beta is given as 0, so it is the normal case with a surcharge which is not inclined. So we can take K as 1 minus sin phi upon 1 plus sin phi as regularly we have used. Let us go to numerical. Problem number 5. A retaining wall 6 meter high retains cohesion less soils. Cohesion less soil must be there, then and then we can apply this theory. Having unit weight 20 kN per meter cube and angle of internal friction phi is given as 30. If surface of the backfill slope upwards 15 degree to the horizontal, so beta is given as 15 degrees. Determine active thrust per meter length of wall using Rankine's theory. So let us solve this example by writing given data first. Total height is given as 6, gamma 20, beta 15 and phi 30. Now we can understand this like that. Surcharge angle is given as 15 degrees. So the surcharge will be inclined, and K can be found out with the formula we have discussed earlier, and K I am getting is 0.373. In this case, if I got K right, then everything will be easier. So PA, pressure force, active earth pressure force, will be 1/2 Ka gamma into H square. So 1/2 into Ka into gamma into H square, putting all the values, H is equal to 6, gamma 20 and K as 0.373. I am getting PA, pressure force, as 134.28 kilonewton per meter. So it is very easy if you understand every theory. Let us move to next theory given by Rankine only, case 5. Inclined back. If the retaining wall is having inclined back, like you can see it here, ACB, right? It is an inclined back. It is not a straight back. It is inclined back. In this case, what will be nu? Let us understand this. Now here pressure PA can be calculated of the triangle as usual. For the triangle will be as usual K into gamma into H. There will be nothing new. But triangle ACB will make some new changes. So for that we have to calculate weight, or we have to get weight of triangle ACB. You can see it in the figure. If it is imparting W weight on the retaining wall, then P can be written as under root P1 square plus W square, just like Pythagoras theorem. But P1 here will be like this, 1 by 2 K into gamma into H square. So let us move to the numerical and then we will go to passive force. Here a 4-meter high wall is given for a mass of flattened dry sand. So dry sand, that is cohesion-less soil only, right? The dry sand's unit weight is given as 18.3 kilonewton per meter cube and internal angle of friction phi is given as 36 degree. What is the magnitude of earth force P on 1 meter wide wall slice, assuming that wall does not deflect? So if the wall does not deflect, it is the case of earth pressure at rest. Now calculate the earth force P1 if the wall deflects sufficiently to generate active pressure conditions to the backfill. So now it is case of active earth pressure. Assume that the back face of the wall is frictionless. So it is smooth as assumed in the theory. Now let us write given data. H is given as 4 meter, phi 36 and gamma 18.3 kilonewton per meter cube. Now we have to calculate this problem by dividing into two types. First, earth pressure at rest, and second, active earth pressure. Let us write them. If the wall does not deflect, then it is case of earth pressure at rest. So in this case K will change. K will be 1 minus sin phi only. This is discussed already in previous lectures. Now phi is given as 36. Putting value of phi, K0 is 0.412. Now I got K0. We can say K0 because it is earth pressure at rest. Now P0 is equal to K0 into gamma into H. Gamma I have that, H I am given. So putting pressure P0 as 30.15 kilonewton per meter square. Now if I want to convert this into pressure force, earth pressure at rest, now taking it as a earth pressure force, then we have to multiply it with 1/2 base into height, and base will be our pressure and height is given already as 4 meter. So P0 pressure force will be 1/2 30.15 into 4, that will be 60.30 kilonewton per meter. Now it will act at where? It will act at 1/3 of height of the triangle, as we can call it CG of the triangle. So 1.33 meter above base it will act. Now in the second question, in the same problem, it is told that find out for active earth force what will be the distribution of pressure and active earth thrust. Case of active pressure. Here Ka will be 1 minus sin phi upon 1 plus sin phi, where phi is given as 36 degrees. So Ka value comes out as 0.259. Now if I am getting Ka right, then it will be easier, as Pa will be K into gamma into H and Pa force will be triangle area. Let us find out K as 0.259, gamma as 18.3, H is given as 4 meter, and Pa will be 18.95 kilonewton per meter square. Now I got pressure. I want to find out pressure force. So area of the triangle will be 1/2 base into height. 1/2 base will be pressure. So I am taking 1/2 into 18.95 into height is 4 meter. So Pa will be 37.9 kilonewton per meter, and it will again act at the CG of the triangle, and it will be 1.33 meter above the base. So this question was asked in two different styles. One is earth pressure at rest and second one is active earth pressure. So let us move forward. So active earth pressure by Rankine theory for cohesive soil. In this case, we have to assume a retaining wall and some different type of pressure diagram. For this pressure diagram, how it will come, how it is evaluated, let us understand this. Here, from shear strength and stress distribution, we got this sigma 1 is equal to sigma 3 tan square alpha plus 2c tan alpha. Here, sigma 1 and sigma 3 are major and minor principal stresses. We know it very well. Now, if we are considering a retaining wall with a smooth back and having some backfill behind that, and for any depth z, we can say sigma 1 that is gamma into z and sigma 3 as PA active earth pressure. Now, considering these both values as major and minor principal stresses, we can say we can put both the values in the upper equation, equation number 1. We can say gamma z is equal to PA tan square alpha plus 2c tan alpha. Here, if I want to make PA a subject, I will get equation like this. PA is equal to gamma z cot square alpha minus 2c cot alpha. Now, we have to remember these both equations and furthermore some marked equations. I will mark the equations which you have to remember. Furthermore, this equation is known as Bell's equation. Now, if I want to find out at ground level, or we can say at the top of the retaining wall, where Z depth will be 0. So, at 0 depth, we can put the value of Z is equal to 0 here. I am getting PA as minus negative 2c cot alpha. Now, this negative value makes the pressure diagram like this. So at top, at z is equal to 0, there will be a negative value like 2c cot alpha. You do understand the pressure at top now. Let us move forward. For here we have marked both these equations. Now I am putting PA as 0 because I want to find out depth of tension crack. Because in same pressure diagram, if the retaining wall is feeling negative as well as positive values of the pressure, then it will break in between both of them. As you have learned in mechanics of solids, the point of contraflexure, it will behave like point of contraflexure and it will have some tension crack. Here, if I am putting PA is equal to 0 and I want to find out the point where PA will be 0. So, putting PA 0 in this equation, it will be like this, and gamma z is equal to 2c cot alpha upon cot square alpha, where if I want to find out the z depth, at which depth PA will be 0, then it will be 2c upon gamma cot square alpha, and we can say 2c z is equal to z0 is equal to 2c by gamma into tan alpha, because 1 upon cot square alpha can be written as tan alpha. Again, we have to remember this formula too. This is showing depth of tension crack. If you are asked to find out depth of tension crack, you can apply this formula directly. And if I want to find out critical height, HC, up to where I can go without any disturbance, so HC will be 2 times Z0, 2 times of depth of tension crack. So HC will be 2 into Z0 as 4C upon gamma tan alpha. So this height is known as critical height of the retaining wall. After that, there will be cracks. Total pressure is given by PA is equal to gamma H cot square alpha minus 2C cot alpha, as we have seen previously. But net pressure can be given as gamma H cot square alpha. You have to remember this formula also. Now, if the backfill is with surcharge, in the case of cohesive soil, if the backfill is with surcharge, then I will calculate it as PA is equal to gamma Z cot square alpha minus 2C cot alpha plus we have to add backfill, and it will be K into Q or Q into cot square alpha. We will take Q into cot square alpha at Z0 is equal to 0. I will get PA value as Q cot square alpha minus 2C cot alpha. Now, if the at Z0 PA will be also 0, then it can be given as Z0 is equal to 2C by gamma tan alpha minus Q upon gamma. So we have to remember these 5 formulas for cohesive soil and active earth pressure. Let us go to some numerical. An unsupported excavation is to be made in a clay layer. If gamma is equal to 18 kN per meter cube, C is equal to given as 30 kN per meter square, phi as 10. Calculate depth of tension crack, calculate maximum possible unsupported length, and draw active pressure distribution diagram. So we have to understand which is the case. Here C is equal to given something and phi is equal to given something. So it is a case of cohesive soil, and it is a case of active earth pressure because I am being told that find out active pressure distribution, right? So let us write given data gamma 20, C 30 and phi as 10. Active earth pressure distribution will be like this because we have seen that in the cohesive soil there will be at top negative pressure and at bottom positive pressure. So negative pressure will be having value 2C cot alpha, positive or net pressure can be told as gamma H cot square alpha. Now let us move forward and find out different values. Alpha is equal to 45 plus phi by 2. We know that formula from previous chapters. Here phi is given as 10 degrees, so alpha will be 50 degree. So let us find out first item, depth of tension crack. For depth of tension crack, I will use formula Z0 is equal to 2C by gamma into 10 alpha. If it was given as surcharge in the backfill, then I would use 2C by gamma tan alpha minus Q by gamma. Now putting values of C as 30, gamma as 18 and alpha as 50, I am getting Z0 as 3.973 meter. Now I got depth of tension crack. Let us find out second item, maximum possible unsupported length. So it is indirectly told to we find out HC or critical height. Critical height formula will be 2 into Z0. So 2 into 3.973 will be 7.945 meter. So it is second item. And the third item, for that active pressure distribution, we have to calculate pressure at top and pressure at bottom. Then we can say 2C cot alpha value will be something like this and this will be like this. Then we can plot pressure distribution diagram. So at top 2C cot alpha negative value will be there. Putting C and alpha value in the equation, I am getting pressure at top will be minus 50.34 kN per meter square, and pressure at bottom will be given as gamma H cot square alpha minus 2C cot alpha. So putting value gamma H alpha and C, I am getting pressure at bottom 50.34 kN per meter square. Now if you want to plot active pressure distribution, then you have to draw a diagram in the same shape and put the values of at top here 50.34 negative and positive 50.34 on bottom. So this is how you can plot active pressure distribution diagram. That's it for this lecture. We will continue earth pressure in the next video. Thank you.